The Boeing F-47 NGAD is shaping up to be the most ambitious leap in aviation design since the rise of modern stealth aircraft. It's not just a new jet, it's an entirely new idea of how the United States plans to stay ahead in a fast-changing aerospace environment. In this video, we explore why the F-47's design matters, what makes it radically different from anything flying today, and how this next-generation platform could redefine future air operations. Let's break down the full picture. The growing interest in the Boeing F-47 NGAD begins with a simple reality. Many of today's advanced aircraft were created for a world that no longer exists. The F-22, for example, remains a highly capable platform, but it was conceived in the late Cold War and refined in the early 2000s. It excels in precision flight, sensor fusion, and stealth shaping, yet its limitations are structural, not a matter of software upgrades. A fleet of fewer than 200 aircraft can only stretch so far, and their operational range was never meant for the extended distances that now define Pacific region missions. Meanwhile, international aerospace development has accelerated in ways the designers of the early 1990s could not have predicted. Several nations have invested heavily in advanced platforms with longer reach, improved sensors, adaptive avionics, and large-scale manufacturing pipelines. The result is a global environment where technological progress and fleet expansion both occur faster, narrowing the advantages that once seemed decades ahead. This shift creates a capability gap that no amount of incremental upgrading can fully close. Extending the service life of older platforms helps in the short term, but range, payload capacity, and internal architecture are bound by the airframe's original design. You can upgrade sensors, enhance electronics, and refine coatings, but you cannot stretch the wingspan or dramatically increase fuel capacity without creating a new aircraft entirely. With many jets already serving for over 2 decades, maintenance requirements also increase, which affects availability rates and long-term reliability. Another factor contributing to this gap is the rising importance of distributed operations. Modern aerospace strategy places heavy emphasis on flexibility, endurance, and resilience in the face of long distances and evolving detection technologies. This environment demands platforms that can perform confidently without depending on extensive support networks or predictable refueling patterns. In many scenarios, tanker reliance becomes a limiting factor. If an aircraft must always remain within a certain radius to refuel, its operational envelope shrinks, and its mission options narrow. The challenge is clear. Bridging this gap requires more than refinement. It requires a purpose-built platform designed from scratch for emerging operational needs, with extended reach, greater adaptability, stronger digital integration, and an architecture that evolves rapidly instead of through decade-long upgrade cycles. The F-47 NGAD is Boeing's answer to this challenge, and it aims to close the gap before it widens further. What sets the Boeing F-47 NGAD apart is not just its next-generation design, but its intentional focus on the exact challenges outlined in Section 1. The F-47 is being engineered for scenarios where long distances, advanced detection networks, and rapid response coordination are the defining factors. Its most talked-about feature is its extended combat radius, described as reaching into the 4-digit mile range. This shift is not merely impressive, it's transformative. It means missions that once required careful timing, tanker support, and predictable corridors can now be approached with greater independence and flexibility. The second standout feature is its multi-spectral survivability. Instead of focusing solely on radar stealth, the F-47 integrates shaping, materials, thermal management, and electronic emissions control into a seamless defensive ecosystem. This helps reduce detectability not just from traditional radar systems, but from infrared tracking, passive sensors, and emerging detection technologies. This integrated approach reflects how modern sensing relies on layers of systems working together rather than one dominant mechanism. Speed and efficiency also play major roles in the F-47's design philosophy. While details remain classified, it is widely understood that NGAD platforms prioritize sustained high-speed flight without compromising range. This combination, fast, efficient, and stealth-optimized, provides strategic benefits beyond simple maneuverability. It shortens reaction times, expands mission windows. The most forward-leaning idea behind the Boeing F-47 NGAD is that it doesn't operate alone. Instead, it serves as the central node in a new family of systems that blends crewed and uncrewed aviation into one coordinated ecosystem. This is a fundamental shift away from older operational concepts where a single aircraft type carried out missions independently. The F-47 is envisioned as the leader of a network, guiding a series of collaborative platforms with different specialties. A major part of this ecosystem is the emergence of collaborative combat aircraft, uncrewed platforms designed to operate alongside the F-47. These vehicles can extend sensor reach, provide electronic support, act as additional payload carriers, or take on tasks that would be too risky for larger, crewed jets. Their role isn't to replace the F-47, but to multiply its capability. This creates a force package where one pilot can direct multiple assets, enabling greater coverage, flexibility, and tactical creativity. Such teamwork is possible because the F-47's digital systems are built for rapid communication, data fusion, and real-time decision support. Instead of acting as an isolated aircraft, it becomes a command and coordination tool, collecting information from satellites, sensors, ground nodes, and uncrewed systems, then distributing that information to create a unified picture. In fast-changing environments, awareness becomes the decisive element, and the F-47 is designed to elevate that awareness dramatically. Another advantage lies in the concept of scalable mass. Producing hundreds of crewed aircraft is expensive and slow, but producing smaller uncrewed systems in greater numbers provides both resilience and adaptability. If one system becomes outdated, new versions can be integrated quickly without redesigning the central aircraft. This creates a constantly evolving formation around the F-47, preventing technological stagnation. From a strategic standpoint, this approach offers long-term sustainability. Instead of relying solely on a single platform's capabilities, it builds a layered ecosystem where improvements can be added modularly. Missions can be customized based on need, some emphasizing extended sensing, others focusing on communications, guidance, or endurance. The F-47 becomes the core, but not the whole story. This philosophy marks a new era in aviation design, one where flexibility, teamwork, and adaptability matter as much as raw speed or stealth. The F-47 stands at the center of this transformation, guiding a more dynamic and resilient aviation ecosystem designed for the future's most complex challenges. Thank you for watching. If you enjoyed this deep dive into the Boeing F-47 NGAD and how it's reshaping future aviation, feel free to like, share, and subscribe for more exciting breakdowns.